Hello grade 9 learners, have a nice day. Welcome back to my channel. For today's video, I'll be discussing to you on laws of exponents. Before we go on further, let us try to understand about the exponent. The exponent tells us how many times a given quantity is taken as a factor. Exponent is also called power. In example 7 squared, 7 is the base and 2 is the exponent. If we're going to simplify 7 squared, that is equal to 7 times 7, not 7 times 2. So 7 squared is just equal to 49 because 7 times 7 is 49. Now let's begin with the first law of exponent. The product rule. Product rule states that when we're going to multiply like bases, we have two other exponents. Examples. Quantity of 3x squared y cubed times negative 5xy. So in here we have to multiply first the numerical coefficient. Here we have 3 and negative 5. Then the variable x, we have to copy. Here we have 2 as our exponent. And on the other hand, we have here 1. So we have to add 2 and 1. Again, we get 2 from this. And the 1 is coming from the exponent here of x. Though you are not able to see 1 as an exponent, but it's already understood that the variable has an exponent of 1. Next, we have here the variable y. Then in here we have 3. So we have to add 3. And the second exponent here is 1. That's why we have here 3 plus 1. Now let's simplify further. So that is 3 times negative 5 is equal to negative 15. And of course, we have to copy the variable x. We have here x. Then 2 plus 1 is 3. Then the variable y. 3 plus 1 is 4. So this is now our answer. Negative 15x cubed y to the power of 4. Second example. Quantity of a cubed b to the power of 4 times quantity of a squared b cubed c. So we have to add again the exponents of the base that are similar. So we have here a and a. So a, and then the exponent here is 3, and then we have here 2. Next, for the b variable, we have here 4, and here we have 3. So we have to add 4 and 3. And lastly, we have to copy only c. Okay? Now, we have to simplify further. So we have a to the power of 3 plus 2, and 3 plus 2 is equal to 5, while b will have an exponent of 7. So 4 plus 3 is 7, and then just copy c. So this is our answer, a to the power of 5, b to the power of 7, c. Now let's have the second law of exponent, that is power rule. When we raise a base to two exponents, we multiply those exponents together. Okay, this is all about power rule. So let's have an example. Quantity of c to the power of 5 squared. Okay, so what are we going to do with this is we will have to multiply the two exponents. So we have to copy the base c and then multiply the exponent 5 and here we have 2. So we have 5 times 2, and that is equal to 10. So we have c to the power of 10 as our answer. Third law of exponent, we have power of a product rule. When we have a product raised on exponent, we can simplify by raising each base in the product to that exponent. So example, we have here quantity of 3x squared y cubed to the power of 4. So we have to raise each base in the product. So here 3 will be raised to the power of 4, and then here x squared, okay, it will be also multiply by the exponent 4, and then we have here y cubed. Y cubed will also be multiplied with the exponent of 4. So simplify. So 3 to the power of 4, it means we have to multiply 3 4 times. So that is 3 times 3 is 9, times 3 is 27, times 3 is 81. So we'll have 81 here. And in here we have x, the variable x, copy, then 2 times 4 is 8. Next, for the variable y, we have 3 times 4, and that is equal to 12. That's why our answer is 81x to the power of 8, y to the power of 12. Another example, quantity of negative 2a to the power of 6, b to the power of 5 cubed. Then we have to raise its base to the power of 3. So we have here negative 2 to the power of 3 times, the second one is a to the power of 6. Then it will be multiplied by the exponent 3. Then we have here b to the power of 5. It will be multiplied again by the exponent 3. Simplify. Negative 2 to the power of 3, so it means we have to multiply negative 2 3 times. So negative 2 times negative 2 is 4 times negative 2. So we have here negative 8. And then here we have to copy the variable a. 6 times 3 is 18. And then copy the variable b. 5 times 3 is 15. That's why our answer here is negative 8a to the power of 18, b to the power of 15. Let's move on with the fourth rule, the quotient rule. When dividing like bases, we subtract their exponents. Okay, remember we have to subtract their exponents. Say for example, we have here x to the power of 8 over x to the power of 5. So to solve for this, we have to copy the common base, which is x, and then subtract the exponent. We have here 8, and then in the denominator we have the exponent of 5. So 8 minus 5, and that is equal to 3. Therefore our answer here is x cubed. Another example, c to the power of 4, d to the power of 6 over c squared d. Okay, so here we are dealing with two variables or two bases. So we have c and then 4 minus 2. Do not subtract the exponent if they have different variables. You only subtract the exponent to the base or the variables that are the same. Just like here, we have c. So we have only to subtract the exponent in the denominator part for c. And for d, consider also the denominator of d in the denominator part. So we have here 4 minus 2. And then for d, we have 6. And d has an exponent of 1. So Always remember to subtract. Then we have to simplify. So of course, c to the power of 4 minus 2. So 4 minus is 2. And d to the power of 6 minus 1. So 6 minus 1 is 5. That's why our answer here is c squared d to the power of 5. Now let's have the next law of exponent, power of a fraction rule. When we have a quotient raised to an exponent, we can simplify by raising each base in the numerator and denominator of the fraction to that exponent. Say we'll have example, quantity of m squared over n raised to the power of 5. So in here, we're going to raise both the numerator and the denominator to the power of 5. So we have m squared to the power of 5. On our denominator part, we have here n to the power of 5. Then we have to simplify further. So of course, we have here m to the power of 2 times 5, that is equal to 10, over n to the power of 5. So this is now our answer, m to the power of 10 over n to the power of 5. Another example, quantity of 7x cubed over 9y squared to the power of 3. So we have to raise the numerator 7x cubed to the power of 3. But in here we have numerical coefficients, so we have to raise 7 to the power of 3 times x cubed to the power of 3 over 9 to the power of 3. Then here y squared to the power of 3. Simplify further. 7 cubed, that is 7 times 7 is 49 times 7 is 343. And x to the power of 3 times 3 is 9. That's why we have here 343x to the power of 9. And in our denominator part, we have here 9 to the power of 3. So 9 times 9 is 81 times 9 is 729. Then here we have y to the power of 2 times 3. And of course, 2 times 3 is equal to 6. So this is our final answer. 343x to the power of 9 over 729y to the power of 6. Next, law of exponent, zero exponents rule. Any number except 0 is raised to an exponent of 0, it is always equal to 1. Always remember that any number, even if it is 1 million, as long as it is raised to the power of 0, the answer is always 1. But remember, 0 to the power of 0 is undefined. So that's why there is an exemption of 0 to the power of 0. So let's have an example. Say we have here 7 to the power of 5 over 7 to the power of 5. Of course, we all know that the answer for this is 1. Okay, applying the previous law of exponent, so we have to subtract the exponent, so they have the same base, so 7. 5 minus 5, that is equal to 0. 7 to the power of 0, that is equal to 1. Another example, 8x squared, y to the power of 0. In here, y to the power of 0 is equal to 1, so we'll just multiply. So just copy 8x squared, and y to the power of 0 is equal to 1, so we will multiply 8x squared times 1, and that is equal to 8x squared. Next, quantity of 4x squared y cubed to the power of 0, and of course that is equal to 1. Now let's have the last law of exponent, negative exponents rule. This says that negative exponents in the numerator get moved to the denominator and become positive exponents. Negative exponents in the denominator get moved to the numerator and become positive exponents. Only move the negative exponents. Okay, let's consider the first example. We have here p to the power of negative 1. Okay, according to the rule, we have to move the term or base with exponent either to the numerator or to the denominator. So in here, it's in the numerator. So we have to move p to the power of negative 1 to the denominator. What shall we do with that? So of course, in order that we can move this, so we have to write 1 as our numerator. Okay, 1 as our numerator, and then we have to copy this p, but this time the negative sign is already removed. We have already 1 over p to the power of 1. And we all know it that if the exponent is only 1 and it's positive, we're not going to write in the positive 1 exponent. Unless if it is negative 1 exponent, we really have to write it. So therefore, our final answer now is 1 over p. Again, in order for this negative exponent to be removed, we have to write 1 as our numerator, and then we have to copy this one, place this in the denominator part, but remove the negative sign. Okay, another example. Quantity of 3x to the power of negative 3. Okay, we have 1 as our numerator, and then you copy this quantity of 3x and then to the power of 3. So here, we already removed the negative sign. Then we'll simplify, applying the previous law of exponent. So we have 1 over 27x cubed. So why we have 27x cubed? So this will be raised to the power of 3. So 3 cubed, that is 3 times 3 times 3, and that is 27. And then x cubed, so we have here x cubed. So our answer is 1 over 27x cubed. Next, 1 over quantity of 5m to the power of negative 2. So in here, the negative exponent is in the denominator. So we have to move this to the numerator. So our answer now is we have quantity of 5m to the power of 2. Okay, why we have this? Okay, before this, let me show to you the detailed solution. But if we are going to familiarize the ruling, we come up with this. Okay, the detailed solution for this is that we have to copy 1. Okay, 1 in our numerator part. Okay, this one has a negative exponent of negative 2. As what I have said, in order for the negative sign to be removed, we have to place this in the denominator. But we have 1 again as our numerator. So the equivalent for quantity of 5m to the power of negative 2 is 1 over quantity of 5m square. Okay? So again, we just copy here 1. Then the equivalent of quantity of 5m to the power of negative 2 is 1 over quantity of 5m square. So we do not have any more the negative sign. Now we have already the complex fraction. So how are we going to simplify this one? So that is 1. Then the denominator part, we have to get the reciprocal. So the reciprocal of 1 over quantity of 5m squared is just equal to quantity of 5m squared. So no need to write 1 since the denominator is already 1. Okay? So this one, then multiplied by the reciprocal. So the reciprocal of 1 over quantity of 5m squared is quantity of 5m squared. Okay, so once you multiply this one, it will give you an answer of quantity of 5m squared. Okay? But if you're already familiar with the law, then you will have directly this answer. I just show this to you just in case the numerator is not 1, it can have another numerator, so at least you will be aware that the process is that you multiply. Okay? Good that in here our numerator here is only 1. But if the numerator is 2, then we have to multiply. So that's why our answer here is quantity of 5m squared. And then we have to simplify. Okay, we have 5 squared, applying the previous law, then m squared. So 5 squared, and that is equal to 25. And then m squared, so we have 25 m squared as our final answer. Last example. 144s cubed t to the power of negative 4 over 9r to the power of negative 2, s to the power of 5, t to the power of negative 2. So first, we have to divide the numbers 144 over 9. Okay. The numerical coefficient. So we have 144 divided by 9. Then r to the power of negative 2, that is times 1 over r to the power of negative 2, multiplied by s cubed over s to the power of 5, multiplied again by t to the power of negative 4 times t to the power of negative 2. Simplify. So 144 divided by 9, that is equal to 16. Okay, 1 over r to the power of negative 2. So this will be moved to the numerator, just like example here, letter C. So we have already here r squared in the numerator part. Then s to the power of 3. 3 minus 5, that is negative 2. So we have already here s to the power of negative 2. Next, t to the power of negative 4. Negative 4 minus negative 2, that is negative 2. Now, simplify further. So, 16r squared will remain in the numerator, while the 2 will be in the denominator. So we have s to the power of negative 2, so this becomes s squared, and t to the power of negative 2 becomes t squared. So this is now our final answer. 16r squared over s squared t squared. Always remember that exponential expressions are said to be in the simplest form if all the exponents are positive, there are no powers of powers, each base appears only once, and all fractions are in simplest form. Thank you so much for watching, guys. Kindly like and write your questions in the comment box. Kindly share to other students for them to learn, especially to the grade 9 students. And please don't forget to subscribe to be updated for more math lesson videos. Before I end, let me share to one of the verses from the Bible. Every prudent man dealeth with knowledge, but a fool layeth open his folly. Proverbs 13 verse 16. That's all for today, and God bless you all.